Hello, my name is Matt Zapurdock. I am a math teacher and math team coach at Jordan High School in Durham, North Carolina, and this is a live solve of the 2017 AIME 1. I have not seen these problems before, so I'm looking at them for the first time, and I'm going to talk through my thought process as I work on them. So, let's go. I'm going to look at the last 5 problems first and just read them. Consider arrangements of the 9 numbers 1, 2, 3, ... 9 in a 3 by 3 array. For each such arrangement, let A1, A2, and A3 be the medians of the numbers in rows 1, 2, and 3 respectively, and let M be the median of A1, A2, A3. Let Q be the number of arrangements for which M equals 5. Find the remainder when Q is divided by 1,000. Okay. Call a set S product-free if there do not exist A, B, C in S not necessarily distinct, such that AB equals C. For example, the empty set and the set 16, 20 are product-free, whereas the sets 4, 16 and 2, 8, 16 are not product-free. Find the number of product-free subsets of the set 1 through 10. Okay. For every m greater than or equal to 2, let Q of m be the least positive integer with the following property. For every n greater than or equal to Q of m, there is, how does that work? Least, okay. There is always a perfect cube k cubed in the range n less than k cubed is less than or equal to m times n. Find the remainder when the sum from m equals 2 to 2017 of Q of m is divided by 1,000. 14. Let a greater than 1 and x greater than 1 satisfy log base a of log base a of log base a of 2 plus log base a of 4 minus 128 equals 128, and log base a of log base a of x equals 256. Find the remainder when x is divided by 1,000. 15. The area of the smallest equilateral triangle with one vertex on each of the sides of the right triangle with side lengths 2 root 3, 5, and root 37 as shown is m root p over n, where m, n, and p are positive integers. M and n are relatively prime, and p is not divisible by the square of any prime. Find n plus p. Smallest equilateral triangle. Alright, time to start with number 1. It says 15 distinct points are designated on ABC. The 3 vertices A, B, and C, 3 other points on side AB, 4 other points on side BC, and 5 other points on side CA. Find the number of triangles with positive area whose vertices are among these 15 points. Let's draw it. It doesn't seem to matter what kind of triangle I draw, but I'll draw a scalene triangle. 3 other points on side AB, 4 other points on side BC, and 5 other points on side CA. I see the 15 in total, including ABC. Find the number of triangles with positive area whose vertices are among these 15 points. So if we do 15, choose 3, we get the number of sets of 3 points, but then we have to subtract the degenerate ones. And it's degenerate if 3 are along the same side. I'm trying to think if there's any other way that we can have a degenerate triangle. No, the only way is 3 collinear points. And there's no other sets of 3 collinear points. So a line can only intersect a triangle in 2 distinct points. It's convex. So minus, how many ways are there to mess up by choosing 3 within this set? 5, choose 3. How many ways are there to mess up in this set? 6, choose 3. How many in this set? 7, choose 3. This equals 15 times 14 times 13 over 3 times 2. All right, let's calculate each of these individually. This is 5. And 14 and 2, this becomes 7. 7 times 13 is 91. 5 times 91 is, divide by 2, 455. 5 choose 3 is 5 choose 2, which is 10. 6 choose 3 is 6 times 5 times 4 over 3 times 2 is 20. 7 choose 3 is 7 times 6 times 5 over 3 times 2 is 35. Add these three up, we get 565. So it's 455 minus 65, which is 390. Okay. Next problem. When each of 702, 787, and 855 is divided by the positive integer m, the remainder is always the positive integer r. When each of 412, 722, and 815 is divided by the positive integer n, the remainder is always the positive integer s, which is not equal to r. Find the sum of these four. So this means 702 is equivalent to 787, which is equivalent to 855, which is equivalent to r mod m. And 412 is equivalent to 722, is equivalent to 815, is equivalent to s mod n. Okay, so if they have the same remainder, then m divides the difference. So m divides the difference here, 85, and m divides 13 plus 55 is 68. And that incorporates all the information from this. We can do, it divides the GCD, so I'm going to do Euclidean algorithm on these two. Subtract 68 from 85. 17, 68, and 68 is 17 times 4, so we get 17. That means m divides 17. And if m is 1, then the remainder would be 0, so m equals 17. Now let's reduce one of these mod 17. So we know 680 is a multiple of 17. That means 702 is equal to 22, which is 5 mod 17. So r is equivalent to, r equals 5. Just as another check, let's say 787, 468, 107, 17 times 5 is 85, 17 times 6 is 102. So we do 6, 102, and the remainder is 5. So let's check with that one. M is 17, R is 5. Now we got to deal with this one. Again, n divides the difference. So n divides, difference here is 310. n divides this difference, which is 815 minus 722, which is 93. So now let's take the GCD. 310, 93. Let's do 93 times 3. We get 9, 27. So we can do 310 minus 279. 31. Oh, I could have just divided by 10. Okay, so this is equal to 31. And again, n has to be equal to 31. And then, let's see, divide. Let's reduce 412 mod 31. So we get 1, 102, 3, 93, 9. So that means 412 is equivalent to 9 mod 31. For a double check, let's do 722, 2, 62, 102. Also reduces to 9. 722 is 9 mod 31. Okay, so S is equal to 9. And our answer is M plus N plus R plus S, 7, 8, 13, 22, 6. So we have 6, 2. Okay, and I checked that reasonably well as I went. Let dn be the units digit of 1 plus 2 plus ... plus n. Find the remainder when this sum is divided by 1,000. We know it's going to be periodic. So we can't just take mod 10 because we actually care about adding up all the units digits. So I think we may actually need to, but I'm hesitant to actually write it out until we find a pattern. Let's at least start. D sub 1 is equal to 1. D sub 2 is equal to 1 plus 2 is 3. D sub 3 is equal to 6. D sub 4 is equal to 0. D sub 5 is equal to 5. D sub 6. So now the nice thing is I can just add 6. D sub 7 is equal to add 7, you get 8. D sub 8 is equal to add 8, you get 6. D sub 9 is equal to add 9, you get 5. D sub 10 is equal to add 10, also get 5. So now there's some kind of periodicness that's going to go on. Which is that D sub 11 is now equal to 6. D sub 12 is now equal to plus 2 is 8. So there's a plus 5 pattern. So I can just look at these and just kind of follow these along. And that seems to be a pretty good idea. The other thing is, since it's +5, the pattern only takes 20 to repeat. So let's just do this. Easy to figure these out now. So the sum of the first 20 is 4, 10, 15, 16, 24, 30, 40, and then it's 14, 15, 20, 26, 29, 30. Expect it to be the same mod 5, so that's reassuring. The first 20 give you 70. How many sets of 20 are in 2000? 100. So that means we have 100 times 70 plus one more set of 20. So one more 70. And then we subtract 2020, 2019, 2018. Let's actually write this. Subtract 2018 also. Subtracting those three should give me the right thing. So this is divisible by 1,000, and we end up with 69. Okay, that I'm pretty uneasy about. Easily could have made a mistake. A pyramid has a triangular base with side lengths 20, 20, 24. The three edges of the pyramid, from the three corners of the base to the fourth vertex of the pyramid, all have length 25. The volume of the pyramid is m root n, where m and n are positive integers, and n is not divisible by the square of any prime. Find m plus n. Okay. So the base, let me draw the base. I'm just drawing this in 2D. We've got 20, 20, 24. And by symmetry, these are the same length. So it's got to lie on this line somewhere. I guess it could be down here even. Those are all 25. So if those are all congruent, 25, 25, 25, then we have three triangles. These are vertical triangles, 25, not sure, height. These must all be congruent. So in a two-dimensional picture, those are all congruent. That means this is the circumcenter. And if I know, means this is big R. That means if I know R, I Yeah, if I know r, then I can find h. So let's do it, maybe law of sines. A over sine A is equal to 2r. Here's my triangle. That's 12. This is 3, 4, 5, so that's 16. I didn't say which one is A, but let's say this is A. So that means 20 over sine A, which is 4/5, is equal to 2r. So that means, let's make this 10, get rid of the 2. 10 equals 5. Oh, no. Let's simplify the left side. 10 times 5/4 is r. So r is equal to 25/2. Okay. So for some reason I'm not that confident about what I just did. But that means we have 30, 60, 90 triangle here. 25/2, 25, 25/2 root 3. And we just need the area. The volume is 1/3 times the base of this thing, and the base is 1/2 24 times 16. That's the base, and then multiply by the height, which is 25 over 2 root 3. Now let's simplify. 24 divided by 2 is 12. 12 divided by 3 is 4. 4 divided by 2 is 2. So we get 2 times 16 times 25 root 3. Let's make 100. 2 times 4 times 4 times 25 root 3. 8 times 100 root 3 is 800 root 3. And we get 803. I'm just a little nervous I didn't use law of sines correctly, so I'd like to come back to that. A rational number written in base 8 is AB point CD, where all digits are non-zero. The same number in base 12 is BB point BA. Find the base 10 number ABC. Okay, it seems, I mean, I can quickly write 60, no, that's not the 64th place. 8a plus b plus 1/8 c plus 1/64 d is equal to base 12, 12b plus b plus 1/12b plus 1 over 144a. Find a, b, c. So we just need to solve for a, b, and c. So my thought also, though, is that this is like a even, the fraction can be written as something over 64, but it can't be written as something over 8. And it can be written as something over 144, but not something over 12. So that means if we have a number like, let's say the rational number is m over n, that means n divides 64, n divides 144, n does not divide 8, n does not divide 12. This means it's a power of 2, so n equals 16, 32, or 64, but 144 is 16 times 9, so that means n has to be 16. We're assuming here relatively prime. Okay, so if you've got a number that's something over 16, it's not something over 8. But it's halfway between two things that are over 8. So that means d is equal to 4. Can we say anything about base 12? Looks like I multiply the number by 16. Yeah, I don't know. I could multiply this through and try to deal with that. I kind of like the approach I have going here. So maybe just think about the integer part of it. There's like the integer part and then the rational part. And if I just think about the integer part, I get 8a plus b equals 13b. So 8a is equal to 12b. Divide by 4, 2a is equal to 3b. A and b are digits in base 8. So either a is 3, and b is 2, or a is 6, and b is 4. Could be either of these. Maybe I think it would be helpful to think about What is 1/16 in base 12? One 16th is equal to so how many times does 1/12 go into it? 2/12 is already too big. This is equal to 1/12 plus something. If we do 1/16, whoa, 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 no, no, no. Sorry. This is 0/12 plus something over 144. It's 9 over 144. So as I go through these things, I got 0.09. That's 1/16 in base 12. And then .16. And then plus another 9. We carry the 1, 3. This, just to check, this is 4/16, which is 1/4. Makes sense. 39.46 and 53.60. Okay, and this has to be BA. Oh, okay. It can still be this or this, except it can't be 0.46 because this is 6/16, which is 3/8. And that's not good, because then D is 0. So you've got to have A is 3, B is 2. And then we're talking about 3/16. In which case C is equal to 1. So the answer is 3, 2, 1. I really like that problem. Okay. A circle is circumscribed about an isosceles triangle whose two congruent angles have degree measure x. 2 points are chosen independently and uniformly at random on the circle, and a chord is drawn between them. The probability that the chord intersects the triangle is 14 over 25. Find the difference between the largest and the smallest possible values of x. Gotta draw the circle first. I don't have a good intuition for this just from reading the problem. 2 points are chosen independently and uniformly at random on the circle, and a chord is drawn between them. The probability that the chord intersects the triangle. Okay, so if the chord doesn't intersect the triangle, you're talking about it lying entirely within those, maybe in this part, or in this part, or in this part. So we have to do geometric probability. We imagine unrolling the circumference there. And let's call this arc length S, S, and scale it so the circumference is 1. And then let's call this 1 minus 2s. So we got S, we got S, we got 1 minus 2S. 0 is less than S, it's less than 1/2. This is S, this is S, this is 1 minus 2S. And if the chord does not intersect the triangle, then we're talking about this part, or this part. Conveniently, the whole area is 1. So the probability that the chord intersects the triangle is 1 minus these three areas, S squared, and 1 minus 2S squared. This has to equal 14 over 25. Yes? Okay. If 1 minus this is 14 over 25, then this 2s squared plus 1 minus 2s squared is equal to 11/25. And then this becomes 1 minus 4s plus 4s squared. So we get 6s squared minus 4s plus 1 is equal to 11/25. So we get 6s squared minus 4s plus 14 over 25 equals 0. Let's divide by 2. 3s squared minus 2s plus 7 over 25 is equal to 0. Okay, so I'm thinking about factoring, but also I'm wondering whether this is going to have reasonable solutions at all. I multiply by 25, I get this. Okay, so you solve this, you get two values of s. There are only two solutions. And I know that x is equal to half of this. It's a degree measure. Half of the degree measure of s. Oh, how do I get the degree measure? Okay, it's proportional, so s over 1 is equal to x over I don't know why this is so hard for me. Take the degree measure, or sorry, take the length and multiply it by, there's 360 degrees in 1 total. And x is 1/2 times 360 s. So it's 180 times s. Just to check, if s is 1/2, then x is 90, which makes sense. So the difference in values of s, how do you do this? Oh, okay. We need to just think about the quadratic formula. S is negative b plus or minus square root of b squared minus 4ac over 2a So the difference in x is 180 times the difference in the s values. So we get 180 times, the difference is 2 times square root of 50 squared minus 4 times 75 times 7 over 150. Okay, cross out the 0. I need more paper. So it's 18 times 2 times, I want to factor out a 25, so 25 times 2 times 50 minus 4 times 3 times 7 over 15. This becomes 18 times 2 times 5 root 100 minus 12, 12 times 7, 4 over 15. The 5 and the 15 give us 3 on the bottom, 18 and 3 give us 6 right there. So you have 12 root 16, 12 times 4 is 48. This seems like it's pretty checkable. So hopefully I'll have time to come back to it. All right, number 7. I like that one too. For non-negative integers a and b with a plus b is less than or equal to 6, let t of a comma b equal 6 choose a times 6 choose b times 6 choose a plus b. Let s denote the sum of all t of a comma b where a and b are non-negative integers with a plus b less than or equal to 6. Find the remainder when s is divided by 1,000. Okay, the first thing I notice is t of a comma b is equal to 6 choose a, 6 choose b, 6 choose 6 minus a minus b. So this seems like it has some counting interpretation. Like, let's say we have 3 colors, red, green, blue, and we know we have A red ones, B green ones, and then 6 minus A minus B blue ones. Oh, except, okay. There's like a there's a replacement kind of thing going on, it seems. So let's call it, it's more like 3 tags. There's like the A tag, there's the B tag, and there's the C tag. You get 6 total tags. And you put them on 6 people. And the sum of all t a comma b seems to be a number of ways to do that. Let's just check. They're non-negative integers with a plus b is less than or equal to 6. So that corresponds to, if we let c equal 6 minus a minus b, then saying a plus b less than or equal to 6 is equivalent to saying a plus b plus c equivalent to saying c is non-negative. A plus b 6 equivalent to c non-negative. Six total tags, put them on 6 people, but there's a rule. A person can have at most 1 of each. So you can't put 2 A's on someone, and you can't put more than 2 A's on someone. Well, this counts it by thinking about how many of each tag first. Wondering if this is a good approach that I'm taking. The people are distinguishable. How else would you do this? How else would you count this? A So you could decide how many each person gets. And then make a decision about which ones they get. if I thought about it as these are three different sets. So each person can be in one of the I'm considering generating functions. A person can be in, if they're in no sets, there's only one choice. And if they're in one set, there's three choices. And if they're in two sets, there's also three choices. And if there have three of these tags, there's just one choice. And then there's 6 of those. And we want the coefficient of x to the 6th. And that's nice because that's 1 plus x cubed to the 6th. And then we have 18 choose 6. Okay, now there should be a better interpretation of this. Okay, there's like 18 total possible tag to person, A, B, C for each one, and then you're choosing 6 of those. So now we just need to calculate it. 16, 15, 14, 13 divided by 6 times 5 times 4 times 3 times 2. 18 cancels out with 6 times 3. 16 divided by 8 is 2. 15 divided by 5 is 3. Let's do 17 times 13. It's 221. Okay. So you have 221 times 14 times 2 times 3. Let's do 14 times 6. Should be 84. Now let's do 221 times 84. 4, 8, 8, 8. 8 times 2 is 16. 8 times 2 is 16. 4, 16. 9 plus 6 is 15. Just feeling uneasy about that, so I'm going to do it the other way. 84. 2 times 84 is 8. Oh, what am I doing? 2 times 8 is 16. 8, 4, 6, 5, 6, 4. Okay. Number 8. Two real numbers, A and B, are chosen independently and uniformly at random from the interval 0 to 75. Let O and P be 2 points on the plane with OP equals 200. Let Q and R be on the same side of line OP such that the degree measures of POQ and POR are A and B respectively, and OQP and ORP are both right angles. The probability that QR is less than or equal to 100 is equal to m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so here's my OP. If those are both right angles, Q and R are on the same side, so we have a circle. Let's draw a semicircle. And that's 100. We're choosing the angle measures of P, O, and the or A and B. So we have something like this. P, O, R. If the angles are chosen uniformly, then the distances along here are chosen. We could think about the distances being chosen uniformly, and probably that QR is less than or equal to 100. So there's like this is the range of places where they could be. And I think we need, so if it equals 100, say it equals exactly 100, then we have an equilateral triangle, and this is 60 degrees. That means this is 60 degrees, which means that this is 30 degrees. So it's the probability that A and B are within 30 degrees of each other. We have another geometric probability problem. 75, 75. And we got a square like this. And if you solve this, you get two lines with slope of 1. So we're talking this probability. And you might as well reduce it. So this is 2 and 3. I'm dividing by 15. 2 and 3. This probability is 1 minus, let's not just do it all at once. The triangles are 9 halves, 9 halves. So in total the two triangles are 9 over total area of 25, and the shaded area is 16 over 25. So we have 41. All right, I'm an hour in. I think I need like a break for a couple minutes. I'm not going to stop the camera. So this is a live solve. I'm going to stand up and get a drink. I'll leave my watch right here so you know I'm not cheating. Nah. Maybe you'll just have to trust me. hour and 5 minutes in, ready to continue. It says let a sub n equal 10 if for each integer n greater than 10, let a sub n equal 100 a sub n minus 1 plus n. Find the least n greater than 10 such that a sub n is a multiple of 99. Let's just calculate a few terms to get a feel for it. A sub 10 is 10. A sub 11 is 100 times 10 plus n, where n is 11. We only care if a sub n is a multiple of 99, so let's just work mod 99, in which case our formula is a sub n equals a sub n minus 1 plus n. Okay, so a sub 10 is 10, a sub 11 is 10 plus 11, a sub 12 is 10 plus 11 plus 12. So in general, a sub n is equal to 10 plus 11 plus dot 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 plus n, which is equal to the number of numbers here, which is n minus 9. For example, if n is 10, there's one number, times the average of the numbers, which is n plus 10 over 2. So we need 99 to divide n minus 9, n plus 10. If 99 has no factors of 2, so multiplying it by 2, this is multiple of 99 if and only if this is. Okay. And if you think of it as a modular congruence, the lowest has got to be less than or equal to 10 plus 99. There's got to be a solution mod 99. And leaving it factored is good. We can, it's equivalent to say 9 and 11. And more than that, these differ by 19, so they can't both be divisible by 3. So we either need n, 9 has to divide one of them, so n is either equal to 0 mod 9, or n is equal to 8 mod 9. And this means either n is 9 mod 11, or n is 1 mod 11. This should give us 4 solutions. If we find all 4, we can be sure this is -1, this is -2, okay. So if n is 0 mod 9, 9 mod 11, that means n is 9 mod 99. That's bad. It's going to be really high. And 0 mod 9, 1 mod 11. It could be 23, 34, 45. Okay. If n is 8 mod 9, 9 mod 11. Then n is equivalent to, let's look at the 9s and subtract 1. So 8, 18, 17? No. 27, 26? No. This might be easier. Negative n is 1 mod 9, 2 mod 11. So 13, no. 24, no. 33. 35, no. 44, 46, yes. So that's 46. N is 99 minus 46, which is 40. 40? No. 53? Let's just check that. This is 8 mod 9. That's 9 mod 11. Okay, last case is N is 8 mod 9 and 1 mod 11. So we've got 12. No, it's got to be 1 less. Multiple 9. 12, 23. No. 34. Just check that. It's 1 less than a multiple of 9. It's 1 more than a multiple of 11. So I think 34 is our answer. Let's just check. Does 99 divide? 34 minus 9 is 25. 34 plus 10 is 44. That seems totally wrong. Yeah, this is not negative 1 mod 9. Okay. I think it's going to be high because this one was low. It's not 34. It's not 45. 56. No. 67. No. 78. No. 89. Yeah, I think it's 89. It's 1 mod 11. It's 8 mod 9. Yes. So the smallest should be this one, 45. 36 times 55. Yes. So 45. All right, number 10. Let z equal 18 plus 83i, z2 is 18 plus 39i, and z3 is 78 plus 99i, where I is square root of negative 1. Let z be the unique complex number with properties that z3 minus z1 over z2 minus z1 times z minus z2 over z minus z3 is a real number, and the imaginary part of z is the greatest possible. Find the real part of z. I think a geometric interpretation is going to help. We have this. Z1 is somewhere up here. Z2 is somewhere down here. Z3 is up here. And it says Z is the unique. Okay. So z3 minus z1 is like this vector. z2 minus z1 is this vector. So z3 minus z1 over z2 minus z1 is equal to it's like a some kind of rotation complex number. That's theta. This equals r times e to the I theta. Okay, so and all in all, we found that the angle formed Z2, Z1, Z3 is equal to theta. And so the second term, we're looking at the angle Z. What's in the place of Z1? Well, this one's written differently. Okay, it's the same as Z2 minus Z over Z3 minus Z. So this is the second term, and then this is equal to Z3 minus Z over Z2 minus Z to the negative 1. Now it's in the same form. If this is raised to the negative 1, let's call this theta 1, theta 1, theta 1. And let's say that Z2Z, Z3 is equal to theta 2. When we multiply the two complex numbers, we're going to get constants times e to the I theta 1 times e to the negative I theta 2. So we need theta 1 minus theta 2 e to the I times this is a real number. So we need theta 1 minus theta 2 is a multiple of pi. Yeah, so I think that means if they're equal, that's certainly good. We can imagine like a circle here. So theta 2 equals theta 1, or theta 2 is equal to theta 1 plus pi. I'm trying to convince myself, is that like the rest of the circle? it's over here, the angle you can think of as being a negative number. Yeah, I think so. I don't want to spend too much time trying to convince myself of this, but I think it's true. And it says find the real part of z. In other words, imaginary part is as great as possible. So we're trying to find basically the x-coordinate at the center of the circle. Okay, I think I can do this. Because this, let's just use regular coordinates. We've got 1839, 1883. So this perpendicular line is y equals the average of those two. 83 plus 39 is 122. Divided by 2 is 61. So y equals 61 is one of those. And this is 7899. And there's like a, I think these numbers look really nice. The slope here is, the rise is 60, the run is 60, so the slope is 1. The midpoint of that is the average plus 30 from each, so 48, 69, and we have y equals slope of -1 for the perpendicular line, negative x minus 48 plus 69. Y equals negative x. Go ahead and plug in the 61. We're finding the intersection of the two, plus 48 plus 69. So x equals, subtract 61, you get 8. X equals 56. Okay. Now the last 5. Consider arrangements of the 9 numbers. Okay, this is the 3 by 3 array. The medians of the numbers, and then the median of the 3 medians, and the number of arrangements for which m equals 5. There's no ties, so you have to have one row has to be 5. And then you just have to make sure you don't have 3 all below or 3 all above. And it's the number of arrangements. I'm thinking that it's almost like 1, 2, 3, and 4, those numbers are interchangeable for the sake of this. I'm going to guess that and we'll see if it's true. So here's my process. Place the 5 9 choices. Then we have to choose the other numbers in the same row. So our process there is going to be choose a number less than 5, 4 ways. Choose a number greater than 5, 4 ways. And then there's 2 spaces available. Choose the order. There's 2 ways. Now we've got one row. It's got a median of 5. So now we've got 6 more numbers. 3 are greater than 5. That's very confusing way to write it. 3 are greater than 5. 3 are less than 5. And most of the configurations are good. The bad ones are when we put oh, no, maybe not. Okay. If we put all 3 greater than 5 on one row, then we're good, because then that has a high median, the other one has a low median, and 5 is the median of the medians. Let's say we put so we put 2 greater than 5 on one row. That's also good, because then there'll be 2 less than 5 on the other row. 2 greater than 5 on one row, that'll have a median bigger than 5. 2 less than 5 on the other, that'll have a median less than 5. So we're using a fact: if 5 is a median of a row, it is median of A1, A2, A3. I think I'm convinced. So we have 9 times 4 times 4 times 2, and then there's 6 more, and we do 6 factorial. So we got 9 times 4 times 4 times 2 times 6 times 5 times 4 times 3 times 2. We know 6 factorial, 720. We know this is 2 to the 5th, or 32. 9 times 32 times 720. Let's do 32 times 9. Two times 8 is 16. 2 times 8 is 16. Plus 1 is 17. 2 times 2 doesn't matter. 7 times 8 is 56. Nothing else matters. So we get 6, 360.